Okay, so I'm going to be talking for the next 45 minutes about Unity's brand new GUI system, which isn't on our website or anything. So this is like an exclusive first in Poland, of all places. So yeah, nice. Cool. So every time I do a talk, I like to find out a bit more about you guys. So, for example, put your hands up if you're a programmer. So you're friends with artists, right? No one laughed. Okay, cool. Well, put your hands up if you're a 2D artist. There's like one per, yeah, okay, couple 3D artists. Okay, cool. Who's a student? Okay, a couple, who's their teacher that's taking them on the school field trip? No one, right, okay. Who's from Poland? Right, okay, you're all waking up now just a bit. Who's not from Poland? Okay, a couple of people, that's cool. I'm not from Poland, obviously. I've got a, yeah, my accent kind of gives it away. So, who's made a Flappy Bird clone? No one wants to admit it. Yeah, we all have, come on. Cool. Sweet, so yeah, I'll crack on with it. I like to use this picture because it kind of wakes everyone up, your game developers. You normally set your alarms for about 1 p.m., whereas this picture kind of like frightens people in the morning and stuff. So yeah, my name's Andy Touch. So I work at Unity Technologies as a product evangelist for EMEA. I'm still trying to explain what that is to my mum. She's a bit worried for me. She thinks I'm like a Scientologist or something, but yeah. But basically, my job is to travel around Europe and basically show off new features to developers to see your games and kind of help you out. So if you have like a prototype, concept, something that is a bit buggy or not finished, or a finished release game, bring it over to the booth, I'll play it, I'll have a look at it, I'll recommend. I like playing games as much as making them, so bring your games, because I like games and stuff. So yeah, you can contact me on Twitter, but it's not like a super corporate Twitter. It's more like I moan about the weather in England. But I do have an email, and I'll give that at the end. So yeah, by the way, this talk's full of terrible jokes, so I'm kind of warning you like in advance already. Sweet. So I'm going to be talking about Unity's brand new GUI system, but I'm going to talk about the old stuff first that no one likes. So the first one is GUI game object. So, oh, by the way, put your hands up if you used Unity before. Okay, put your hands up if you don't know what Unity is and you just saw like a big bunch of people and you saw new on like the slide and you're like, yeah, this might be cool. Okay, sweet. So you all know what I'm on about when I say this method sucks. So basically, GUI game object was the first method of creating GUIs in Unity, and these were very static. This is basically like text and images which are rendered in the scene view, but not in the game view, but not in the scene view. For example, with the original GUI system, it was kind of like really simple and basic. So for example, you'd have your text rendered in the game view, but then where is it in the scene view? I can't actually edit it, I can't view it, I don't know where it is. It's all kind of like being rendered here, and it's all really basic, like, hello, Digital Dragons, which is a pretty sweet name for a conference. So it's all very simple. So artists loved it because they could just like dump in fonts and images and they have their pretty art, but programmers didn't love it. Gaffer tape makes everything better. Yeah, so artists were like, yes, my art is in the game. They could bring it in, they could drop it in. It's being rendered in the game view, my beautiful art. Programmers were like, wait, what? How do I actually make this into a scrolling slider bar? It just makes everything look squashed. It makes everything look horrible. How do I do a scroll bar? That doesn't make sense. So naturally, artists liked it, programmers hated it. The other one was OnGUI. Naturally, everything was written by code. So for example, artists loved it because they couldn't actually see anything of it. You had to draw everything by code, and you didn't actually see what your GUI looked like until you run the game. So naturally, programmers are like, yes, I can do what I want. Whereas artists are kind of like, where is my art? Show me my art. Where's my beautiful art I've just slaved away making? So you kind of have this divide. You kind of have, the artists like one, but programmers hate it. Programmers like one, but artists hate it, which is a really bad divide to have, because they should be working together and being friends. So at Unity, we kind of had this phrase called DNF GUI, which was the GUI system, what it was called for years and years and years. And lots of people were speculating what DNF means. So some people think did not finish GUI because it was being in development so long. Other people thought it was Duke Nukem Forever GUI because it's going to take like 15 years to make. And we kind of went through several iterations. But when we released our GUI system, we kind of want it to fit all these nice iterations, make it work on mobile as well as consoles, and have this broad range. People got a bit bored, so what they decided to do is they decided to make third-party plugins like NGUI and EasyGUI and sell them themselves. For example, the guy who made NGUI, he made, I think, 900 grand last year, and he has a pretty nice car. So yeah, he's living a nice life. We basically hired him to make our new GUI system because he's kind of like the pro. So we brought him on board and actually said, hey, do you want to make a nice, pretty GUI system? He's like, okay, and he's making that for a while. So eventually we had to get around to actually making it, which is what I'm going to be talking about. So from Unity 4.6 and beyond, so next version of Unity is 4.5, which comes out soon, and then 4.6 after that. It will be in the free version as well as the pro version. That's got UGUI, our brand new GUI system. And I'm going to be talking for like the rest of this talk, the next 40 minutes, about how to what it is, how to build it up, and sort of like the basics around it. But I have to have a beta warning here, because things may go a little funky, because as all betas do, you're all programmers and game developers, you've all had prototypes kind of fail on you in front of hundreds of people, whereas when you're in your bedroom, like it works perfectly 1,000 times, and then when you actually demo it, it kind of goes a bit wrong. So I've got my beta warning slide here. So one thing a lot of people say to me about new GUI system is, how is it different or how is it similar to existing stuff? I don't want to learn a brand new system on top of what I already know, because that's going to take time. And it's been integrated well with the 2D tools. So I'm going to get you guys to interact again, because no one's asleep. Someone's yawning, so yeah. Put your hands up if you used Unity's new 2D tools that came out in November. Okay, so if you want a good gist of what the GUI system's like, the new one, use those 2D tools. So as the 2D developers are making the native 2D tools and the GUI system's being made, when the 2D tools are finished, the 2D developers went over and helped out the GUI guys, because it doesn't make sense to release 2D physics system and then GUI system, and they're two completely different things. They're kind of like merged together. So we have here the sprite editor. And the sprite editor is a method of taking a sprite sheet and then slicing it up into individual sprites you can use in your UI. So for example here, I have a simple sprite sheet. And what I'm going to do is I've imported it as sprite and set it to be multiple. And in the sprite editor, you then have this kind of like chopping board. So you have your texture sheet of all your atlases and all your UIs and everything. You import that into Unity. You then use the sprite to kind of like chop it up, define what is a sprite that's going to be used in UI. Now, if I was to sit here and slice every single one, I'd have like, until 1:45 to do that, and you'd all be really bored and probably go off and play some video games. So what I can do instead is with this sprite editor, I can actually automatically slice every single UI element. So what it'll do is it'll cycle through the sprite sheet and it'll cut every single UI element for me. Like that. Oh, cool, it's done. So now I have, oh yeah, beta warning has happened already. I even have a digital dragon sign, which I'm actually going to use in the talk. Cool. So what I have here is I've taken my sprite sheet, brought it in. By setting up my slicer to automatically slice, it's basically going around finding any 1 pixel gap minimum, and it's slicing that into a UI element for us to use either in the 2D tools or in anything else. So I'm going to basically rename it so I know what it is. So Digital Dragons. And let's take this as a button. I'm going to apply that. So now what you'll notice in my Unity project folder is I have my sprite sheet here, my texture where I've set up. So you guys at the back, you might need to get some binoculars that they were given out in the gift bags, right? People are nodding, cool. My terrible joke. And what you'll notice here is underneath each of these things, I have an individual cut of each individual element on my sprite sheet. So you can actually take your sprites, bring them into a texture and slice everything up in one texture, and you have all your UI elements you can use. So in this case, I have a button. Now the Digital Dragons logo. Now I'm going to get rid of this because this method of UI is horrible. I'm actually going to start from scratch. So we have our UI elements to use. So the most important thing with this new UI system is the canvas. So if we go into game objects, we can actually create other elements. So it's finally been renamed to Create General instead of Create Other, which is fantastic. I've been waiting that since Unity 3.1. And we now have a Create UI panel here for creating all of our UI. So I'm going to create a canvas, which is the most simple thing you can make. So the canvas here, it's basically a 2D defined area which is going to render your UI onto. And then you can specify that canvas whether it's a 3D UI or a 2D UI and how it interacts with the scene. So if I have my game view, and I'll drop my game view window here, what you'll notice is that the canvas actually changes its size based on your game view. So if you are replicating, for example, a wide iPad, it will then replicate a wide iPad game view. The canvas is kind of like taking in what the game view's elements are, and it's resizing it accordingly. So what you'll notice is that with the 2D tools here, with a little 2D switch, it allows you to go into a 2D edit mode. So everything's visual in the editor, just like everything else with Unity. You bring your character in, you sign up materials, you position them, look at the animation. With the old UI systems, you couldn't see anything, whereas now it's actually all visual in your scene view, ready to edit. So we have our canvas like so. Those of you that have managed to spot it out, we've actually got our rect tool in the corner, which is a brand new UI tool. So for example, if I create a, let's create a sphere. Okay, so I've got a sphere. We have all the usual position, rotation, scale. We now have a 2D handle. So if you're making an entirely 2D game using 3D meshes and elements, you can actually edit 3D meshes using the 2D's rect tool handles, which is similar to something out of After Effects. But I don't want to talk about that, I want to talk about UI. So we have our canvas. So our canvas is kind of like where we're going to put our paint, where we're going to put our UI elements onto. And if you look in the components section here, you'll notice that our canvas has a couple of types of render mode. So we have screen space, where it's going to render on top of your camera, so it's like a health bar or some UI elements and some buttons, or world space. That is now a 3D UI. So it's as simple as that. So if you're making something like Dead Space, where you're walking along, you want 3D UI, you just set your canvas to render in the world space as opposed to it being a screen overlay. But I'm going to do a screen overlay instead. So I have my canvas like so. So when we create UI elements for this canvas, they are all sub-children of this canvas. So if I go to Game Object, Create Empty Child, I now have, inside here, a sub-element of that canvas. So you can have canvases within canvases within canvases and have some form of Inception-y type setup. And you can use canvases to basically draw properties. So you could have a canvas for your game over screen. You could have a canvas for your, I don't know, health bar. You can have a canvas for your buttons and things like that. And each canvas batches all the UI elements as one draw call. So each canvas is one draw call. So yeah, super optimized and nice. So the GUI devs, they didn't think that something like, hang on, let me just put this down here. The GUI devs, they didn't think that something like the 3D gizmo would actually be useful for creating UI. They thought something a bit more like the 2D tools, where you actually have handles and positions around in your scene, would be a bit better. So we have here a new type of transform, a rect transform. And what this does is it basically defines things within pixels. So for example, this canvas is pulling in the pixel size of this game view, and this UI element here is pulling in a pixel size of this UI element here. So as I resize it, I'm basically defining this UI element as such. So I can position it wherever in my screen. So it's a bit boring, so I'm going to add some visual elements. So underneath the component section, we have two types of different UI. We have events and we have UI. Underneath UI, it's going to define all pre-made things for you to use, but you can go in and customize these things if you don't like them, but I'll talk about that a bit later on. So we have images, text, raw image. So for example, you could take a render texture and apply it into your UI to have like a top-down or like a security camera or something like that. So you can actually use and render pretty much whatever you want. So I'm just going to create an image. So we now have an image within our scene, within our game view. And what we can do is we can then define a sprite. So if I take the Digital Dragons logo, I then have that rendered in my game view like so. And it's all fairly visual. It's not like kind of being rendered here but not in your scene view. It's actually, you can actually see where it is and what it's doing. So we have our Digital Dragons logo like so. Now, like the 2D tools, what you'll notice is that you can change the vertex color of each individual sprite. So if I had, for example, okay, so one logo, let's have another one. Someone shout out a color. Anyone know a color? Shout one out. Come on, blue, cool. Some people try and be smart and say white, and then it completely ruins this bit. So yeah, thanks. Some people say pink. Pink is a popular choice. So what it's doing is it's taking the same UI element and it's actually coloring them each independently. And you notice under the stats that it's batching every single thing inside this UI sheet to basically be under one draw call as well, which is pretty sweet. So you'll notice that you could just create a white button and then color that white button whatever color you want. So I've got blue and I've got red. So let's go to this one like so. So I've got my red UI. It has a material slot as well. So what I can do is I can define this to have a 3D material and actually have it have a bump map or be affected by light and things like that, which is pretty cool. And we also have types of image that we can have. So for example here, it's currently simple. So as I resize it, it's kind of going to get a bit squashed and sort of resize it's going to look a bit horrible. We also have a set native size where it will take in what the UI elements actually been imported size as, and it will resize it to that scale, which is handy. We have sliced if we want to do some 9 slicing, but I'll talk about that later on. We have tiled, so if I want the Digital Dragons logo to be, hang on. So I can actually just take kind of like a little background element, and then I can actually tile it across the whole canvas, which is nice. We have filled as well. So filled is actually my favorite one. So filled is what you'd use for like scroll bars and sliders, because you can actually define what is shown and what's hidden by a mask. So I can say, I want it to be filled. I want it to be a horizontal fill across from left to right, and I can actually define that to be a health bar revealing. Whereas with the old GUI texture system, it will kind of take your texture and just squash it, and it will look really horrible. We can actually reveal and hide a health bar. But I'll talk about actual interaction stuff later on. So I've got my UI element like that. Another thing is preserve aspect. So as I resize it, it actually like takes in my aspect and preserves it. It doesn't kind of like squash it and flatten it and look horrible. So if the designer of this logo is currently watching me, he's probably having a miniature heart attack right now as I deface his logo. Cool. So what else? So another problem is scaling UI depending on what platform you're going to publish to. So what a lot of people do at Unity is they tend to make one game, and then they release it on, for example, an iPhone, and an Android, and big screen, Xbox One, PS4, Oculus, all these different resolutions, which previously it didn't really support, and it was kind of a bit horrible. Well, thankfully, we actually have handles which can define the percentage of the screen that our UI is going to take. So the devs hate me calling it this name, but I call it the flower because it looks like a flower, and that's what I'm going to coin. So luckily the devs are in Denmark, so they didn't hear that. And I have no boss here, so that's sweet. So this flower basically defines where it anchors to. So if I took this individual flower and the point, what I can do, so I can actually take this flower, I can actually set it to lock to the corner. So this UI element will always be set to anchor in this corner here. So as I actually resize the canvas, it's always going to sit in the top right-hand corner in no matter what screen. So you have a tiny little iPhone game, you could have your health bar and that there. If you had a bigger screen, they're basically in the corners. But the trouble is if you had like Titanfall on an iPhone device and you have all your UI elements small, then you put it on a massive 4K screen or a screen like this, they're all going to be like that big, and you're going to have to squint or pull up binoculars to see them. So what you can do with this flower is you can define a percentage of the screen it's going to dock to. So for example, I can say, this flower is now, this UI element is now 14% of the size of the screen. So now as I actually change it, I take my canvas, hang on. Okay, let's say it's 100%, why not? Position it in the middle. Actually, I've got a better demo of this bit later on. So it's now sort of central of the screen, it's 42% wide, so as I now actually resize it, we'll then take that UI, hang on, there we go, that's more like it. So what it's going to do is when you're on a little iPhone screen, it'll be positioned like so, whereas when you're on a bigger screen, it will actually scale based on the percentage of its parent rect transform. So yeah, neat. So you can just take this flower and position it. These were originally yellow, which is why everyone's calling it flower, and they changed it white, but I'm still going to call it that. I'm determined to have it coined. I'm going to get rid of that DNF GUI label that the GUI system's getting. So yeah, sweet. So let's get rid of that, and let's make a button. Cool. So what you'll notice, if you go to create UI, we have some pre-made things. So we can have a panel, a button, text. These are kind of like not what you have to use. These are kind of like pre-made constructs of UI elements you could use. You can actually customize it in any way you want. So what you'll notice is that in creating that, we have a button which has a UI image renderer, and we also have a label. So we have some text that's being resized, and the flower is defining to scale the text depending on the size of the button. So if I resize the button, basically the text is kind of positioning itself in the middle, which is nice. And with the text, we could do all sorts of things like hello. We can assign different fonts. We can assign all sorts of things. We can define a wrap mode. So I can actually say, it'll wrap automatically. And then as I change the scale of the button, actually take that wrap mode and kind of like scale it. So if you had an iPhone screen, it will basically scale it accordingly. When you have it bigger, it'll actually be responsive to how big that UI element is based on the flower. So we have a button with some gibberish in it. That's nonsense. So, hello, dragons. If I can type correctly, right? So I have my button like that. So that's very pretty. We can make text, we can make images, which is nice. You could do that before. But how do we actually get it to interact with anything? So what we can do is take any UI element you want. You can actually define it to do any behavior. So whether it's a slider, whether it's a scroll bar. I could take this text and turn that into a scroll bar. So actually I scroll through the text and it will scroll through the text. I have some demos later on which I'll show you where I'll do that. So what you'll notice is that on this button, we have this image being rendered here. It's sliced, so it has a 9 slice on it. So I'll show you that. Or not. Okay, it's in beta, right? Okay. And what you'll also notice is we have a script of button. So underneath button, you have a couple of properties. The first one is the graphic. So you can target what interaction the button has. So when your mouse hovers over it, what does it do? When you click on it, what does it do? Because buttons aren't very stationary. When you actually hover over it and interact with it, they do all sorts of wacky things. So the first one here is none, which is pretty boring. So I can hover my mouse over it and nothing's going to happen. It's going to be pretty lame, pretty boring. And I'm going to have a bubble. Okay, let's go to that. Actually, let's make it bigger so you can actually see what's happening. So the next one, after none, is color tint. So what that does is it takes the sprite and it color tints it depending on the interaction. So on normal, the sprite is white. Then as we hover over it, it's going to change to yellow, and so on and so forth. And we actually define the duration fade. So for example here, what you'll notice is I now have, when I hover over it, it's going to have that state. When I click on it, it's going to do that. So that's really simple if you don't have lots of pretty art for all sorts of different sprites, and you just kind of want to apply a tint to it, have something very nice and simple. Okay, I haven't blown your mind yet, right? So the next thing is we can target what the graphic is. So I'm targeting the sprite and saying, this is the thing that changes with this animation. What I can do is I can target the label and say the label is what changes. So now, when I hover over it, the label will actually change color instead. I spoke too soon. Okay, it's in beta, right? I keep saying this. So we have a color tint, which is nice. We could define the fade duration. The next one is sprite swap. So what this does is if you have different sprites for like normal, then you like hover over it and there's sparkles, and then you push it down, there's a smiley face, and you know, all that stuff, and your artist has kind of drawn all these different UI elements, you can actually define the sprite swap. So I can say, on normal, it's going to be the button. On hover, on highlighted, it's going to go to that button I defined, and on press, it's going to change to the Digital Dragons logo. So now, you can actually swap out different sprites for different things, and it actually retains that information, and it only draws it once. It's not like the previous UI systems where it drew it twice every single frame. Whoever decided that is mad. So the next one is animation, and this is the bit which everyone will love. So basically, you can take your button and you can actually pass it through Mechanim, which is our animator system for the bipedal characters, and animate any element you want. So when I hover over it, I could have it resize, spin, change the font color. I can actually animate any property I want. So I can auto-generate an animation called button. So now I have an entire Mechanim animation system that you'd normally use for like parkour games and stuff like that, all on a button. And you can use this for scroll bars, you can use this for any UI element you want. And you can actually see it all updating in live time. So you'll notice it's currently in a normal state. When I hover over it, it's highlighted, and when I click on it, it's going to go to pressed. So we're actually using a system that's for parkour and like bring in rigs to animate UI, which is pretty mad. So I can now actually say to this, for example, when it hovers over it, I could have it spin each time, I could have it highlight, I could do all sorts of things. So you can actually use Mechanim to drive all your animations, which is pretty cool. Right, so I'm going to go on to something that looks a bit prettier. Let's go with that one. Okay, cool. So we've got a very simple demo. This is basically a 3D canvas. So what I've done, the designers of this project has done is they've taken that 2D canvas, which is overlaid in the screen, and they set it to be a world canvas instead. So this is now actually being rendered within the 3D space in the world. And those of you that don't believe me, lots of people say that. So there is the 3D canvas. And as I hover over it, oh, look, cool, it's tilting. That's nice. So what it's doing is it's actually taking the canvas and it's drawing it within that canvas, which is specified in the world space. And all we're doing is we just have a script to detect where the mouse is, and it's tilting that canvas accordingly. So what you'll notice is that we have some text, we have some images, we even have a button, so that's having a nice little tint, and we have some scroll bars as well. So these scroll bars are animated. What you'll notice is that we can sort of like define the different animation. And we have things like that, which is nice. So what we're doing is we're just toggling on and off different canvases when we click these different buttons. So they're canvases within canvases. So let's actually see what it's doing. So we have our text like that. I can resize it. So basically this text is taking in the sort of the constraints there. If I go to my whole window and sort of resize it, what you'll notice is that the top bits have been told to be 50% width, but anchored to the top left-hand, top right-hand corners. So actually, if I'm on like a little iPhone screen, it's going to kind of look like that, whereas I'm on like a big 4K screen, because I've splashed out a bit just before Christmas, it's going to resize accordingly. Cool. So I can actually resize it, and I have some pretty canvas like that. So we have buttons, we have scroll bars and stuff, but what I actually want to show you is actually what to do with those buttons. So we had that button, it was kind of tinting and doing stuff, but it wasn't really doing much in a sense. And what you'll notice is that underneath that button, or any UI element you want, you can add a component called an event trigger. So what the event trigger does is it detects your pointer data no matter what platform you're on, and it does something accordingly. So for example, if you're on a keyboard and mouse game, the pointer data is your mouse. If you're on an Xbox controller, the pointer data is where your joystick is. If you're on a phone, pointer data is where your finger is. It pulls in exactly the same data for all these devices. You don't have to define mobile, keyboard, Xbox, PlayStation, Wii, Ouya, if you want, so on and so forth. You don't have to define all these different elements. You can actually just get all the pointer data, and it's universal for all of them. So you kind of so I could build this to the device, and it would detect my finger coming onto it and not. So with this button here, which I'm going to sort of like increase the transparency, this is currently just a very simple sprite which has a normal map onto it. And we have a component of event trigger. So under event trigger, I can define what I do with the pointer data. So when the pointer enters this, I can make it do something. When the pointer exits it, I can make it do something as well. So I'm going to say on pointer enter, I'm going to add an event. So this event here is going to ask for what object we want to send a message to and what we want to do with it. So for example, with this here, I can say, okay, where's my bunny? On pointer enter, oh yeah, so that's a 3D object, and it's actually taking in that. So this bunny, what I'm going to do is I'm going to color it red when pointer enter and color it white on pointer exit. When I click it, I'm going to rename it to a dragon or whatever. So yeah, something simple. So for example, what we can do is if we go to that watermark, one problem is we won't be able to see it. So here's some trickery. What we can do is we can actually go to the top canvas. We can change the alpha level of all the UI elements in that canvas like so. So rather than, say like you have a canvas fades in and fades out and sort of changing each individual element, you can actually go to the top canvas and it will have an alpha which will fade in and out all the UI elements. So we can actually have our canvas kind of like semi-alpha. So let's go back to our button. So underneath our button, on pointer enter, we're going to go to the bunny. Underneath here, we have all the functions for all the components on the bunny. So we wanted to do something with the game object, so set its tag, set its name, set its position. We have that there. We can set all the transform properties. We can set its mesh renderer, like what material it uses. We can do all that stuff. We can go to its mesh filter. We can actually go to scripts on the bunny and do something with it. So currently the bunny's spinning. So I can say on pointer enter, make the bunny spin at the speed of like 500 miles an hour, and then pointer down, make it stop. We can actually do those things. If our bunny had an audio source, we could actually use a scroll bar or use a button to change the levels of the audio source and step up and step down. So any component with any property can do things. So I'm going to go to my bunny, I'm going to go to the mesh renderer of the bunny, and I'm going to go to the material of the bunny. So I'm going to go to the bunny, it's mesh renderer, and I'm going to set it a material. So luckily, I've done my homework and I've got a material for red. It's pretty boring. So that's pointer enter, pointer exit. Let's go to the bunny. Let's go to the mesh renderer of the bunny. Let's go to the material of the bunny. And let's set a new material, which is just white. So when I hover, it's red. I hover, it's white. So with the buttons, you can basically animate or sort of access any information you want in the whole UI system. The toggle, for example, will just set a bool. So I could set a toggle. So for example, on a camera, I can use the toggle element to change between the different projection types, different types of clear effect. Anything that can toggle on and off in your component, you can use the toggle and just hook it up and tell it what to toggle. So on bunny enter, it's red. On bunny exit, it's white. However, I've got some more information. So I can say on pointer down, go to the bunny. Hang on. What am I going to do with the bunny? Let's set the bunny's name. So what's a typical Polish name? Someone shouting out. I can't hear any of you, sorry. Dave, what? J-A-N-E-K. Yannick, right. So the bunny has now changed its name from Stanford Bunny to Yannick, right? Let's add another event. So let's say, so what you'll notice is we actually have pointer up, pointer click. We have drag, so we can actually have our element when we drag our cursor down. So when we have our finger and drag in the area, so like Angry Birds, we can then get the pointer data and then pull like the Angry Bird to it. I could have it when I drag across the UI element, it pulls the UI element. I could have it when I scroll. So when I have my pointer over it and I scroll, it will then do stuff. I have select and deselect, so if I have like a keypad, it goes up and down. So you can basically do whatever you want. So I'm going to say, on pointer down, the bunny is going to be changed to Yannick. Another thing we can do is we can say, on pointer down, it not only changes to Yannick, let's go to the text. So this text here. So when we click it, we can actually pass in multiple events. So we could have, when we click a button, it mutes audio, plays a sound effect, plays an animation, transitions to a scene. You can actually pass in multiple event triggers. So we're going to go to the label, so this big text here, and we're going to set the text to say something. What should we say? Set text. Hello, this works. Yay. Cool. So let's see that in action. Oh, look, cool. It's pulling in the pointer data. How cool is that? Oh, look, I'm going to click it, and it's going to go, hello, this works, yay. And what you'll notice is that not only it's changing the visual properties, is if we go to Bunny, our bunny's now called Yannick. Cool. People have had Liam Neeson, Tom Hanks before in testing this out. So yeah, our bunny is now called Yannick. So you can actually set tags. You can basically, using this event trigger system on anything, I could have it when I hover over the text, it actually changes the button's name to Yannick and changes the button to a bunny if I want. Cool. I've got like a couple of minutes. Okay, that's cool. So I can do that. So some of you are probably wondering, how is it pulling in these events? How is it pulling in the event data? So on our canvas, okay, so visual components, any UI element we want to be rendered. So sprites, images, text, masking areas, render textures. So we have buttons, scroll bars. So scroll bars, you literally just attach it. You define what's the handle, what's the scroll bar area, and then you pull in its value between a minimum and maximum value. And I'll show you that bit later on. In terms of event systems, on a canvas, we can catch multiple events. So graphic event system takes in the graphic, and that's the information. So for example, when my pointer hovers over this graphic area, this rect transform, it's going to pull in that information. That's the type of event it's going to catch. That's great. However, we've got some other types of event systems. 3D physics. So this, if you had like, you're walking down a corridor in Dead Space, and then a UI element pops up, you can actually raycast and place 3D colliders on the UI system to catch in raycasting and stuff, which is cool. 2D physics systems. So you can actually use the 2D physics colliders to pull in raycasts and stuff. So that's pretty cool. Gamepad input. So you can actually define when you use pushes up and down, it actually scrolls through an array of UI elements and selects different elements. When they push start, it will then do a particular event and stuff like that. So basically, any canvas can catch any event that you want. Are you with me so far? Everyone's like, or everyone's like, yeah, cool. So let's show you something better. Okay, let's go with this one. So some people ask me, what if I want some 3D elements? So what this is doing is it's taking a camera, it's capturing a render texture, and it's actually outputting their render texture to the image. So we can actually pass things in and out. We could have, for example, this bunny, or we could have like a camera attached to the top of our player and then pulling like a top-down map. We could have the camera attached to a security camera, rendering your texture and then rendering that in the UI. So for example, if I go to my bunny, or Yannick, as he's called now, what you'll notice is we can then sort of do stuff with him. Let's make him bigger. Sweet. So we now have like a bigger Yannick because it's taking that camera and it's outputting it to there just through a render texture. So that's pretty nice. What else can you do? Okay. Okay, people like this one. Okay, so you're making a game similar to League of Legends or World of Warcraft or something with lots of different grid elements like Zelda and things like that. You want to position them all accordingly. That would be a bit of a pain if you had to define a rect transform, then kind of assign and position them individually. What if you're adding to this list? So what if you're getting all your Facebook friends and then say like you've got 1,000 Facebook friends, so you're trying to stack them individually. You don't want to individually place 1,000 elements. So what we have is we have a couple of layouts, vertical, horizontal, and grid. So this vertical, you basically assign your objects into a rect transform, and what it'll do is it automatically stacks them on top of each other as a list. So you can add things to the list and take them away. It's kind of like an array. Grid group more defines things in a big grid. So what you'll notice here is we have, what do we have? We have a grid, and in the grid layout group, we can define how big each individual element is. So I could have each individual element 300 pixels by 300 pixels. We could have, let me just turn off the background, because that's really annoying. Okay, cool. So what we could, okay. So what we can do is we could say each grid layout is 300 pixels by 300 pixels. So what you'll notice is it's drawing each of these. We could then define the spacing to be like 50 pixels by 50 pixels. We can actually take all the children of this grid, you'll notice they're all here, and basically define how they each are. So let's say each one's going to be 5 pixels by 5 pixels, and each element is 100 by 100. Good God, what's it doing? Okay, that looks beautiful. And then we can actually define how it looks. So for example, if we're on a tiny little screen, so like an iPhone screen, we can actually select our group. We can actually say it will only show 3 elements. So for example, you have 3 different like power-ups. However, on a bigger screen, it will actually animate that accordingly. So if I took my window, I can then go smaller screen and bigger screen and so on and so forth. So you can actually place different things in the grid. Another thing you'll notice is there's the 3D effect, but each of these different elements, rather than using a tint or a sprite swap, these are using Mechanim. So what you'll notice is that as we hover over it, it's going to animate the Z position of it out, and then we click on it, it's actually going to go in. So we can actually use Mechanim, and that's one animation controller for every single UI element in the whole grid. So you don't have to make like controller for A, B, C, D, E. You can make one and then use it across all the different elements. Cool. Okay, so I have 5 minutes. Okay. So what we have here is we have a canvas being rendered in the screen space, but rather than an overlay where it's orthographic, it's actually a perspective screen space overlay. So what you'll notice is that the UI elements within this grid what we can do is we can actually use the 3D space and actually rotate it accordingly, and it will treat it like that. So what you can notice is it's actually being rendered in the screen space, but all 3D elements behind it are kind of being rendered behind it, but it's still a 3D different type of canvas. However, if I go to my canvas and I set it to be an overlay instead, it's going to be a bit more orthographic. So you'll notice that it's a bit more locked on. So you can actually define different types of UI like that. Cool. I think I'm almost done. Another thing is the sprite packer. So in Unity 4.5, in Unity 4.3, you introduced a load of 2D tools, so you could bring in your 2D sprites. But if you had lots of different 2D sprites, obviously that's going to be 40 textures you got loaded into your project, as opposed to batching it all into one sprite sheet. Whereas in the sprite packer, which is kind of like the only pro-only feature of the GUI system, sorry, but everything else is free, what it does is it takes all your UI elements, all your sprites, and it packs them into one big texture for you on build. So you can basically build Flappy Bird with all your different UI elements for Flappy Bird, and then that'll bundle it on the build into one texture. So it's basically just piling it all together. So you'll notice there's an example here like that. 5 minutes. Okay, cool. So what else shall I do? That's pretty much it. I rattled through that pretty quickly. So this has kind of been like a bit of a rough hands-on guide. I know there's lots of little fiddly bits and pieces and things like that you have to look at more in depth. I do actually have another example. Hang on. This one. Okay, so we have a very simple slider. Some of you are probably about to ask me how to do a slider. What you'll notice is the slider has your animation graphic. So when you hover over it, what does it do? Well, it's going to color tint. What's it going to color tint? It's going to color tint the handle. So slide a circle. It's going to color tint that handle. So what else is it going to do? We can then pass in the fill rect, which is basically where the slider is going to be. We can also pass in the handle of that, and we can also define what the minimum value and the maximum value is. So if you had, for example, your volume goes from, make a Spinal Tap game, your volume goes from 0 to 11, you can then define that your slider is going to be between 0 and 11. Here I've currently got it between 0 and 1. We can define it to be whole numbers. We can actually change the slider value and see what it's going to look like. What you'll notice in the 3D view, I have all the UI elements, and they're all being rendered at different depths. But because my camera is of a overlay, my canvas is of an overlay, it's basically going to render it accordingly. So what you'll notice is what I also have is on my handle, I have another canvas somewhere. So I actually have a canvas rendering all this, and then a canvas just for this little handle there, and then the slider is actually outputting its number to that individual UI element. So what you'll notice is that as I go in here, as I change the slider value, it's actually changing the alpha of the canvas, and that's really, really small. It's also changing the number as well. So I'm pulling in that number, and that's just being passed in as a float. So any sort of scroll bar, slider, gets passed as an integer or a float, or a string if you want to. If you're using a toggle, you can pass it in as a bool or a 0 and 1 integer. Basically, you're just passing in normal numbers and materials into your UI. I have 2 minutes. Sorry. And that's pretty much the end. I know I've sort of rattled through it, and I've sort of shown off like the canvas, UI elements, and things like that. Don't ask me when it's released. That's like the one question that everyone's been asking me for so long. But when it comes out, it will be in the free version and the pro version, Unity 4.6. Sprite Pack is the only pro-only feature, but you can use the sprite editor to batch all your things together, so that's nice. I have a Twitter as well, but I kind of like just moan about the weather and post pictures of cats and stuff. And I actually have an email, so if you're actually making a game, send me the game and I'll play it and I'll test it out for you. I'll say, oh, you might need to optimize here, or we have a new feature coming out here which might help you here, or just ask me how my day is and ask you how your day is. Or perhaps you're saying, oh, I'm from Poland. When are you next coming to Poland? Because do you want to come to office and stuff? So yeah, just send me emails and stuff. I like emails. So thank you.